Hello everyone, welcome to this video on the request library in Python, one of the most powerful and widely used tools for making HTTP requests. If you've ever wondered how to interact with APIs, fetch data from the web, or automate web-based tasks, the request library is the perfect place to start. In this video, we'll break down everything you need to know from the basics of making simple HTTP requests to handling advanced features like custom headers, JSON data, and more. Let's dive into this essential library that every Python developer should have in their toolkit. What is the request library and why use it? The request library is a powerful and widely used Python module designed to simplify the process of making HTTP requests. When working with web communication, developers often need to interact with servers, retrieve data, submit forms, or perform other web-based operations. The requests library abstracts the complexities involved in managing HTTP connections and provides a clean, intuitive, and user-friendly interface to perform these tasks efficiently. One of the key strengths of the request library lies in its support for a variety of HTTP methods, making it highly versatile for interacting with web servers. The get method is commonly used to fetch data from a server, whether it's retrieving content like HTML pages or querying APIs for specific information. The post method allows you to submit data to a server, making it ideal for tasks such as sending forms or JSON payloads to APIs. If you need to update existing resources on a server, the put method comes into play, providing a straightforward way to modify data. Finally, the delete method is used to remove resources from a server, offering a reliable way to handle deletion operations. Together, these methods cover a wide range of web communication needs, making the request library an essential tool for developers. The request library also provides effortless handling of JSON data, making it ideal for communication with modern APIs that primarily rely on JSON for data exchange. This feature allows developers to send and receive JSON payloads seamlessly, significantly simplifying interactions with web services. Additionally, the library supports custom headers and cookies, enabling developers to include crucial information such as authentication tokens, API keys, or other metadata required by servers. These features make it easier to build secure and flexible web-based applications. Another powerful capability of the request library is its ability to maintain persistent sessions. This feature allows developers to reuse settings like headers or cookies across multiple requests without the need to reconfigure them every time. This is especially useful when working with APIs or web services that require consistent authentication or state management. In terms of use cases, the request library excels in several key areas. It is widely used for interacting with APIs, where it facilitates making HTTP requests to fetch or send data to web services. It is also a valuable tool for automating workflows, helping developers streamline repetitive tasks like extracting data, downloading files, or monitoring system statuses. Additionally, it simplifies web-based operations such as fetching data from servers, submitting forms, or uploading files to APIs. Due to its simplicity, reliability, and versatility, the request library has become an indispensable tool for Python developers. Whether you're working on a simple script or a complex project, it provides the functionality you need to interact with the web effectively and efficiently. Why use the request library? The request library is widely regarded as a go-to tool for making HTTP requests in Python because it significantly simplifies the process compared to using lower-level modules like orlib. While modules like orlib require more effort and detailed configuration to manage HTTP connections, the request library abstracts all of these complexities, making it much easier to work with web services and APIs. It's clean and intuitive syntax allows developers to focus on building functionality rather than dealing with the intricacies of HTTP. One of the standout features of the request library is its comprehensive support for various HTTP methods, including get, post, put, and delete. This makes it versatile for a wide range of web communication tasks, such as fetching data from APIs, submitting forms, updating server side resources, or deleting records. Additionally, the library automatically manages cookies and sessions, which is especially useful for applications that require maintaining state between multiple requests. For example, if you are logging into a website and need to navigate through multiple pages, the request library makes it easy by seamlessly handling session cookies. Another significant advantage of requests is its ability to handle both JSON and form data effortlessly. When working with modern APIs that rely on JSON for data exchange, the library provides built-in methods to send and receive JSON payloads with minimal effort. Similarly, for tasks like submitting forms or uploading data, the library's handling of form encoded data ensures smooth interactions with web servers. In summary, the request library combines simplicity, versatility, and ease of use, making it an essential tool for Python developers who work with web communication. Whether you're building small scripts or complex systems, request enables efficient and reliable handling of HTTP requests without unnecessary complexity. Installing the request library. Installing the request library is a straightforward process thanks to Python's package manager pip. This tool makes it easy to download and install Python packages from the Python package index pipeline. To install the request library, simply open your terminal or command prompt and type the following command pip install request. Once you press enter, pip will download the library and install it in your Python environment. After the installation is complete, it's a good idea to verify that the library has been installed correctly. This can be done by importing the request module in a Python script or an interactive Python session. Type import request to ensure that Python recognizes the module. This will display the version number of the installed request library, confirming that the installation was successful. By following these simple steps, you can set up the request library and start using it for your projects. Whether you are a beginner or an experienced developer, installing and verifying the library is quick and ensures you have a robust tool for managing HTTP requests in Python. Making your first HTTP GET request. Making your first HTTP GET request with the request library is both simple and intuitive, providing a solid introduction to how Python interacts with web servers. The GET method is used to retrieve data from a server, and this example demonstrates fetching a single post from the JSON placeholder API, which offers placeholder data for testing and learning purposes. By using the request.get function, you send a GET request to a specified URL and receive a response from the server. When the code is executed, the first output is the HTTP status code, which indicates the result of the request. A status code of 200 means the request was successful and the server returned the data as expected. The second output displays the raw response body as a string. This data is formatted in JSON and JavaScript object notation, a popular format for transmitting structured data because it is both human readable and easy to pass programmatically. To make the data more manageable, the request library provides a convenient response.json method, which converts the raw JSON string into a Python dictionary. This parsed data is structured with key value pairs, making it easy to access specific parts of the response. For example, the response might include fields such as user ID, title, and body, representing the details of a post. This structured format allows you to use Python's dictionary operations to process the data further. In this example, the GET request returns a post with an ID of 1. The status code 200 confirms the request was successful, while the raw response and pass JSON output show the post's details, such as the title and body content. This example highlights the simplicity and power of the request library, making it an invaluable tool for working with APIs, fetching data from servers, and performing web-based tasks efficiently. Understanding HTTP methods. The request library provides robust support for various HTTP methods, allowing developers to interact with web servers in versatile and meaningful ways. These HTTP methods, including get, post, put, and delete, are fundamental for communicating with APIs and performing essential operations like retrieving, creating, updating, or deleting data on a server. The get method is primarily used to retrieve data from a server. It is the most common HTTP method and is typically employed to fetch content or information from a web resource or an API. For instance, the code response request dot get https colon double forward slash json placeholder dot typicode.com forward slash posts sends a get request to retrieve a list of posts from the JSON placeholder API. A successful response will return the requested data, often in JSON format, which can then be processed and used in your application. The post method, on the other hand, is used to submit data to a server. It is commonly utilized when you need to send form data, create new resources, or interact with APIs that require input. For example, the code response request dot post https colon double forward slash json placeholder dot typical.com forward slash post data title foo sends a post request to create a new post with the title foo. Upon success, the server typically responds with a confirmation such as the details of the created resource or a status code like 201 created. The put method is used for updating existing resources on a server. It allows you to modify specific data associated with the resource. For example, response request dot put https colon double forward slash json placeholder dot typical.com forward slash post forward slash one data title bar updates the resource with ID 1. Changing its title to bar this method is particularly useful when you need to make updates or corrections to previously created records. Lastly, the delete method enables the removal of resources from a server. It is used to delete data or resources that are no longer needed. For example, response request dot delete https colon double forward slash json placeholder dot typical.com forward slash post forward slash one sends a delete request to remove the resource with ID 1. If successful, the server will confirm the deletion with an appropriate response, such as a status code 204 no content. Together, these HTTP methods supported by the request library provide a comprehensive toolkit for interacting with web servers. Whether you are retrieving data, creating new resources, updating existing records, or deleting unnecessary data, the request library makes these operations simple and intuitive, ensuring seamless communication with APIs and web services. Handling response objects. When making an HTTP request using the request library, the server sends back a response object that contains all the details about the server's reply. This response object is a rich source of information, offering several attributes that allow you to analyze and work with the return data efficiently. One of the most important attributes is status underscore code, which provides the HTTP status code of the response. This code indicates whether request was successful or if there was an issue. For example, a status code of 200 means the request was successful, while AE404 indicates that the requested resource could not be found. You can access this attribute using response.status underscore code and use it to verify the outcome of your request. The text attribute contains the entire response content as a string. This is particularly useful when you need to view the raw data returned by the server, such as HTML content or plain text. You can simply print the value of response.text to see the full response in string format. For working with APIs, the JSON method is incredibly helpful. If the server's response is in JSON format, this method automatically passes the JSON string into a Python dictionary. This makes it easy to access and manipulate specific data fields. For example, calling response.json on a JSON response will convert the data into a dictionary, allowing you to work with the return data using Python's built-in dictionary methods. The headers attribute provides access to the server's response headers, which contain metadata about the response. This can include information such as the content type, server details, caching policies, or authentication requirements. You can view these headers by printing response.headers, which will return them in the form of a dictionary. In summary, the response object in the request library offers powerful tools for handling server replies. By using attributes like status underscore code, text JSON, and headers, you can effectively analyze the response, extract relevant information, and seamlessly integrate it into your Python application. These features make the request library a versatile and indispensable tool for interacting with web services and APIs. Practical examples. Fetching data from a public API is one of the most common and practical use cases for the request library. Public APIs provide structured data that can be accessed programmatically, and the request library makes it easy to interact with such APIs. In this example, we are using the JSON placeholder API, which is a free service that provides sample data for testing and learning purposes. To fetch a specific post from the API, we send an HTTP GET request using the request.get method. The URL https colon double forward slash json placeholder.typical.com forward slash post forward slash one specifies that we want the post with an ID of 1. When the request is sent, the server processes it and returns a response containing the requested data. Before working with the data, it is important to check the response's HTTP status code using response.status underscore code. A status code of 200 indicates that the request was successful and the server returned the data as expected. If the status code indicates an error, e.g., 404 not found or 500 internal server error, you can handle it appropriately by printing an error message, as shown in the example. If the request is successful, the response.json method is used to parse the response body into a Python dictionary. This makes it easy to access and manipulate specific fields in the return data. For instance, the JSON placeholder API might return details like the post's user ID, title, and body. Here's an example of the expected output for a successful request. The API response provides details about a post. The user ID identifies the creator of the post, and the ID uniquely identifies the post itself. The title gives a brief summary san dot fese repellent provident okaikati exceptary optio reprehended, while the body contains the main content kia it suscipit nostrum rerum est autem sanremi benet architecto. This JSON structure is clear and easy to interpret. This approach demonstrates how simple it is to fetch data from an API using the request library. Whether you're retrieving posts, user details, or any other type of structured data, the request library provides a straightforward way to interact with APIs and access the information you need. 2. Downloading a file using a GET request. Downloading a file using the request library is a simple and effective way to save web resources locally. This example demonstrates how to use an HTTP GET request to download a PDF file from the internet and save it to your computer. The URL provided in this example points to a sample PDF file hosted by W3C https colon double forward slash www.3.org forward slash va forward slash er forward slash test forward slash html forward slash test files forward slash resources forward slash pdf forward slash dummy.pdf. The process begins by making a GET request to the specified URL using the request.get method. The server responds by sending the requested file as part of the HTTP response. Before saving the file, it's essential to check the HTTP status code using response.status underscore code. Forward, a status code of 200 indicates that the request was successful and the file is ready to be processed. To save the file locally, the response content is accessed via the response.content attribute, which contains the raw binary data of the file. The open function is then used in binary write mode WB to create a new file named dummy.pdf on your computer. Using the write method, the binary data is written to the file, effectively saving the downloaded content. If the status code indicates an error, such as a 404 not found, the script prints an error message with the corresponding status code, ensuring that the issue is communicated clearly. This example showcases how straightforward it is to download and save files using the request library. Whether you're downloading reports, images, or other resources, this approach provides a reliable way to handle files efficiently in Python. That brings us to the end of our introduction to the request library. We've covered the basics of making HTTP requests, explored its powerful features, and seen how easy it is to work with APIs and web data using Python. Whether you're a beginner or an experienced developer, the request library is an indispensable tool for web communication. Keep practicing by experimenting with real world APIs, and you'll quickly master this library. Thanks for watching, and don't forget to like, share, and subscribe for more Python tutorials. See you in the next video.